Okay, so I've got the video now going, so I'm recording now. Okay, what do you want to look at? If you don't know, then I'll pick. Kind of your call.
Maybe 3.5.
Okay. Okay, this is where you're kind of working with doing derivatives of trig functions. Okay, Sage, you're saying the 3.6 stuff. Okay. All right, so we'll go ahead and start with some of these trig problems here. So I got about 4 or 5 trig problems. Okay. So like I said, the one things that you guys need to make sure you have memorized is the derivative of the trig functions. Okay. So just kind of writing over here a little bit, in this first problem, the derivative of the cosecant, first of all, it begins in C, it means it's negative. So what you will have there is the derivative of cosecant is negative cosecant cotangent x, like that. Okay, and then we also have the secant. The derivative of a secant is almost the same thing, except it's cofunctions. It is secant x, not sex. That's a bad slip up on my part. Okay, so we have secant x equals secant x. You call that a Freudian slip, I think is the word for that. So it's secant tangent. Okay, so we got that. So those are the rules you have to know for this problem, but you also have the chain rule on this. Okay, so first of all, when you're doing your derivative, you have a constant too, and if you have a constant times something, you don't do the derivative of the constant, you just write it down. The derivative of cosecant, by definition, is negative cosecant of pi x times cotangent of pi x, but the chain rule is going to tell you to also do the derivative of what's inside, so that will be doing the derivative of pi x like that. And you can do this all in your head. And then the next one, you're doing a derivative of a secant. 3 is a constant, so write it down. Derivative of secant is secant tangent, so it'd be secant pi x times tangent of pi x. And then again, the chain rule is going to tell you to do the derivative of pi x. This is a problem that, you'll see something similar to this on your test. A lot of times students have some issues with the chain rule on this. So it's going to go like this. We'll have negative 2 cosecant pi x, cotangent pi x, and then what we'll have is the derivative of pi x is going to be pi, like that. And then we move over here, you'll have minus 3 secant pi x times tangent pi x, and then the derivative of pi x again is pi. Okay, that is your derivative right there. Simplification on this, you would have to think about trig identities and see that. So let's see, Annie, you're saying why would the derivative of pi not be 0? Okay, well, first of all, I'm not doing the derivative of pi, I'm doing the derivative of pi times x. And that's no different than doing the derivative of something like 7x. It's equal to the number in front. So the derivative of pi x is going to be pi. That's where that's coming from. Do you understand what I'm saying on that? Okay, all right. I thought that was maybe what you were not seeing there. And really, this is an answer to the problem. If you were looking at identities, a cosecant is 1 over sine. A cotangent is a cosine over a sine. So nothing is going to cancel out on this problem. I mean, that isn't going to do you any good, so you don't need to use identities there. Same thing over here. If you had a secant, that's 1 over cosine. Okay, and then tangent is sine over cosine. So the point that I'm trying to make on this is using those identities doesn't help you at all. And there's the only thing that you could do, and I say simplify, so you could leave this as an appropriate answer to the problem, or if you wanted to, you could factor a pi out of that. I don't think there's any need to do that, but you could. If you factored a pi out, you'd have pi times -2 cosecant pi x times cotangent pi x, and then -3 secant pi x times tangent of pi x, like that. So that would be one way to write the answer, would be like this. Okay, so that's how you would handle the derivative of that. Okay, do you guys have any questions about what I did there? Okay, all right. So the next one on here, okay, you have two choices on how to do this problem. The first thing you could do is you could look at this as a product rule. Okay, you can do it that way. I'll show you a simpler way to do this on this problem just as well. So I'm going to just let the first part be 2 sine x and the second part be the cosine. So you want to make sure that you have memorized the product rule, which is the first times derivative of second plus the second times derivative of first. Okay, so what we do here is we're going to have the first is 2 sine x. We're going to multiply that by the derivative of the cosine, which you can do in your head. And then we'll do it backwards. The second is cosine x. And then the derivative of the first will be doing the derivative of 2 sine x. Okay, you could bypass writing that step out because you can do these two derivatives in your head. So we need to do this derivative and this derivative. If we do that, we're going to have 2 sine x. You have to know that the derivative of sine x is negative, or derivative of cosine is negative sine x. Okay, so when I do that derivative, that results in that. Okay, bringing everything down, I have plus cosine x. And then if I do the derivative of 2 sine x, again, 2 is a constant, so it comes down. And then the derivative of sine x is cosine x. Okay, so that's kind of an unsimplified derivative using the product rule. Okay, and then what this is going to be is you could write this as -2 sine squared x plus 2 cosine squared x, like that. Now, is that enough to get full credit? Yeah, it really is. If you left the answer that way, that's fine. There's nothing wrong with leaving the answer that way. Now, what I'm going to go ahead and do is write it this way. There's a reason why I'm going to do this. I'm going to write the 2 cosine squared x minus 2 sine squared x. Okay, now there's a couple of things you could do, but what I'm going to choose to do on here is simply factor out the 2 to leave this. Okay, then I've got an identity. So an identity that you learn is this. Okay, basically the cosine of 2x, there you go, is equal to this part right here. So that part right there would become 2 times cosine of 2x. And then that would be as simple as you're going to make that derivative. Now, on a test, I would take this answer or I would take that answer right there. Okay, both of them are the same. There's a variety of ways to simplify something. Okay, now let me show you an alternative way to do this problem. We have an identity that says the sine of 2x is equal to 2 sine x cosine x. Okay, so the easiest way to do this problem would be to do this. If you go all the way back to the beginning, f of x, since I'm giving you 2 sine x cosine x, well, that's the same thing as the sine of 2x. Okay, now if you do the derivative of sine 2x, the derivative of a sine is a cosine, and then you've got to do the derivative of the inside part, so you have to do the derivative of 2x. So that will result in cosine 2x times 2. And notice that gives exactly the same answer right there. That is two ways to do that problem. It's either product rule, or you could observe that you could change 2 sine x cosine x to sine 2x, and then do the derivative that way. Okay, you guys have any questions about what I did on that problem? Okay, all right. So that'll take care of that. That gives you a couple of ways to do that. Okay, next problem, you could do the quotient rule if you wanted to. Something that's always worth doing when you're doing a derivative of a trig function is to use identities and see if you can simplify it. Because if you do that, it's less work. I'm going to write this as tangent theta. That should be tangent x, by the way, in the problem. So tangent x times 1 over secant x like this. Okay, now the reason why I'm going to use identities is I can make this simpler. The tangent can be written as sine x over cosine x. That's a fundamental identity that you can use. And then this 1 over secant is cosine of x. Okay, and see, this problem's kind of designed to see how many students notice this. That will cross that out. So really, f of x is equal to the sine of x. Now, when you do the derivative, it's real simple. The derivative of sine x is cosine x. So this would be your answer to your problem. That's the simplest way to do that problem. And that's kind of like that part B. It's actually less work to use an identity, changing the 2 sine x cosine x to sine 2x. Okay? If you use the quotient rule and identities, you'll get the same answer. Okay, that's what I say, Annie. Nice. Yeah, okay. You got to learn how to recognize things like that. If you're dealing with trig functions, try to play with identities and make it simpler. There you go. Okay, if you're in the weeds, check your identities. Okay. All right, very good. If you're in the weeds, don't smoke weed. How about that? All right. Any questions about what I just did? Okay. All right. Very good. Okay. So the next one, what we're doing is we're doing a fourth derivative. And, the only kind of problem on this, usually what I ask on the test is to do a third or a fourth derivative. And it's going to be simple functions. Okay. So you kind of start this way. I don't want to hear about your rolling joint stuff. I'm your professor. Okay. All right. That's cool. All right. So the next thing that we have here is let's do the first derivative. So the first derivative, the derivative of sine x is cosine x. And then the derivative of x to the fourth is 4x to the third. And you just keep doing the derivative over and over again like this. So you go to the second derivative, which in Leibniz notation, you write it like that. The derivative of cosine, you have to have memorized, is negative sine. The derivative of 4x to the third is 12x squared. Okay, and then you just keep proceeding through the next two derivatives. So if you do the third derivative, the negative is a constant. That's really a -1, so it comes down. And then the derivative of sine we learned is cosine x. The derivative of 12x to the second by power rule would be 24x. And a problem like this, I'd be giving you partial credit for each step in the process. Okay, so finally, the fourth derivative then would be this. So we have the negative comes down. We have a negative cosine. We learned that the derivative of a cosine is a negative sine x. So I've got negative sine. And then the derivative of 24x is the number in front, 24. So your answer to your problem would be sine x plus 24. Okay, so you just kind of do step-by-step derivatives, and I wouldn't ask you to do more than a third or a fourth derivative. That's as far as you need to really take that. Okay, all right. Any question about what I did there? Now we don't need to go over related rates, Sage, because related rates problems go to the third test. We can do the physics though. Okay, all right. Okay, and I give you a little bit more time to learn about related rates because it's a challenging subject area for students to learn. You need more time to work and practice with that idea. Okay, so let me finish this next thing here, and we're going to do the equation of the tangent line at y equals 2 sine x cosine x like that. So again, you're always using the formula y minus y1 is equal to m times x minus x1 like that. Okay, so we need to just do these basic things. First of all, I've given you that x is equal to pi. So, pi is going to go in there. I need to do a couple of things, okay? When I first need to do the derivative, and I think we did this same derivative a few minutes ago. So the way I did it is 2 sine x cosine x is really sine of 2x. So you could change using an identity, change that to sine 2x. Then the derivative would be cosine of 2x times the derivative of the inside part, which would be 2. So you would end up getting 2 cosine 2x is going to give you your derivative. Okay, and then you have to figure out two other things on this. You need to figure out what f of pi is. Okay, so f of pi, you could either plug that into the original or into the one where you did the identity. So let's just do the sine 2x. So I just do sine of 2 pi, plugging the pi in, and then on a unit circle, when you're at 2 pi, that's one rotation around the circle. So the sine is the y value, so that's equal to 0. Okay, so what you end up getting is you get 0. So that means you're going to plug in 0 for your slope of your tangent line. Oh, hold on, I put that in the wrong place. I'm sorry. So the 0 is going to be that point right there. Okay, so that's what y1 is it's the function value at pi. Then we need to do the slope of the tangent line. So the slope of the tangent line, we're going to do 2 cosine of 2 times pi. So again, I'm taking the derivative, which was 2 cosine 2x. Then we need to do that. So this is going to end up giving you 2. The cosine of 2 pi is 1. So you end up getting 2. So the slope of the tangent line is going to be 2. And then from there, it's a fairly simple thing to finish up. You're just going to have y minus 0 equals 2 times x minus pi. That would be y equals, you don't have to distribute it out, but I'm going to go ahead and do that. That's 2x minus 2 pi. Okay, so that would be that. Okay, you're thinking it's not going to be that simple on the test? I don't know. It just depends on how difficult the derivative is. Could be a little bit more difficult. Could be a little bit pretty straightforward. But the idea is you want to make sure you know how to handle finding an equation of a tangent line, regardless of which function you're looking at. Okay, all right. So let me just see if anybody else is trying to come in yet. So not yet, it looks like. Okay. Okay, like the homework plus or minus a couple of curveballs. Yeah, yeah, that's a good way to look at it. I mean, there's maybe a few curveballs in here, but these are the concepts that you're wanting to learn. Okay, so let's see, 3.6. Somebody was asking about that, I think I saw in chat. And that's mostly chain rule stuff. Okay, so we can go through, I think on 3.6, there's quite a bit of chain rule stuff going on these problems. Okay, we want to go through 12 and 13 because typically what I do is I ask one question where you have to identify u and y and then do the chain rule in this format. Okay, So when I do this, first of all, we're looking at the function y equals the fourth root of 1 minus x to the fourth. Okay, so the u part is the inside part. You want to think of that as a function inside of a function. So the u part is going to be this part, 1 minus x to the fourth. Okay, like that. Okay, and then the y equals is the big part. So the big is going to be y equals the fourth root of u, which can be written as u to the 1/4 power like that. I think I got a couple of people need to trying to come in. Let me let these students in if I see anybody in here. Okay, all right. So we have this, and now we're ready to finish it up. So the rule that you all want to make sure you know how to do is this rule. It would be dy over dx is equal to dy over du times du over dx. Okay, in that, it doesn't matter which order, but when you do this problem, essentially all you're doing is the derivative of both of those functions and then multiplying them together. Okay, so let's do the derivative of y. That would be a power rule. That would be 1/4 u to the 1/4 minus 1, which you can do in your head. And then the derivative of the inside part would be negative 4x to the third. So what you get by doing the chain rule is you have 1/4 u to the negative 3/4 times negative 4x to the third power. Okay, then whatever simplification you do, you want to do that. So you could cross out the 4s, and this would end up leaving us with, you would have u to the negative 3/4 times, and you'd have a negative, you have that negative left over, times x to the third. Okay, the last thing that you always do is whatever u is has to plug back in. So what you would end up getting as your final answer is you would get negative parentheses 1 minus x to the fourth to the negative 3/4 power times x to the third. Okay, that's fine if you write the answer like that. I didn't say in my directions, well, no, I did say write in a radical form. So you would want to write this kind of like this. You would write this as negative 1 minus x to the fourth to the negative 3/4 times x to the third. So you would want to write this as negative x to the third over 1 minus x to the fourth to the positive 3/4. Then change that back to a radical because my directions of my problem say write in radical form. So that's negative x to the third over the fourth root of 1 minus x to the fourth to the third power. So that would be the final answer on the chain rule. So you definitely want to make sure that you know how to do this. Okay. Okay, so again, you got to make the negative exponent positive and then change that back to a radical form. Okay, with this next one, let me kind of get a couple more people in here. Again, what you have in problem 13 is you can think of this problem as sine of x to the fifth power. Okay, so it's going to go like that. So again, the u is the inside part. Okay, so that is going to be just sine x. Okay, and then the big function is going to be u to the fifth. Okay, so we got that. Yeah, I see everybody, 6:30, everybody's coming in, so that's fine. Okay, so we got that kind of put together. That's what you want to do is make sure that you've got the u and the y part. The y is the big function, the u is the part on the inside. Now, when you're doing the problem, you need to know the formula dy over dx is equal to dy over du times du over dx. Okay, so you have to have. Okay, and then we're ready to finish up the problem. So now if you do this, when you do the derivative of y, you do the derivative of u to the fifth, that'll give you 5u to the fourth. You do the derivative of sine x, that's going to give you cosine x. And then the last step is always plugging the u back in. So your final answer, you would get 5 times sine x to the fourth power times cosine x like that. And you could write it that way. It's fine to write the answer that way. Or you could just write 5 sine to the fourth x times cosine x. So that's your derivative. So one of the things you want to make sure that you know how to do is the chain rule when you identify u and y. I always put one problem on the test kind of like that. Okay. All right. You guys got any question about what I just did? I got some people I need to take a break just for a minute here and get everybody written down that's here. So let me go through this. Who's here now? Okay, so we got Adam Hickey is here, Annie McKenzie, Crystal Lucero is here, Dan Endermill is here. Nicholas is just coming in. Okay, Jeff is here. Jonathan is here. Okay, we got Curry Mead. Got Matt. Okay, Matthew Townley. Okay, so I got you. Got Rose Bowers already checked off. You got Sage already checked off. Okay, so I've got everybody written down. Okay, now guys that are just coming in, I am recording this. I didn't realize that I had wrote 6:30 to, what did I write? 6:30 to 8 or something. My intention was 6 to 7:30. And so we'll go to 7:30, but I am video recording every problem that we go through, and then I can post that later on tonight. Okay, let's just start going through and taking some questions. I'll open up the chat and go ahead and kind of see. I'll monitor the chat. Just type in chat some of the problems that you want to look at now. Okay, so Jeff's going to be here the whole time. Okay, all right. Okay, anything that you want to look at? Specific questions? Okay, Dan Endermill would like to look at number 20. So let's go ahead and take a look at what's going on number 20. From here, we're just going to kind of jump around to different things. Okay, this problem right here, the only time I ask for a second derivative, doing it using implicit differentiation, I do that on the extra credit problem. So your extra credit problem will be finding a second derivative using implicit differentiation. Okay, so this will go like this. The first step is we need to do the derivative of both sides of this equation. So we're going to do the derivative of sine y plus 5x. And then we're also going to, not DDT, I'm thinking about related rates problems that I was going over in class. So we're going to do the derivative with respect to x of both sides of the equation. Okay, so the first thing you got to make sure you know how to do is do this part right, like this. So when we do the derivative of a sine, we know that's a cosine. But the variables don't match, so we have to multiply by dy over dx. Okay, you can't miss that part. The derivative of 5x is 5. The variables do match, so you're done with that piece. Then you go over here, the derivative of y squared is 2y. Again, the variables don't match, so you have to multiply by dy over dx. Okay, Now what you have to do is you've got to solve this equation for dy over dx. It doesn't really matter which side you put stuff on. This is just going to be my choice. I'm going to leave the 2y dy over dx on the right side. And then I'm going to move this thing that I'm highlighting. I'm just going to move that to the other side. So that'll give minus cosine y times dy over dx. Okay. And from this part, now what you can do is you can factor that out. And what we'll have is we'll have dy over dx times 2y minus cosine y, like that. And then we can divide both sides by that quantity, and you can do that in your head. So you get dy over dx is equal to, and what we'll have here is we'll have 5 over 2y minus cosine y. What I find typically is students usually don't have that big of a problem with finding the first derivative. Okay? So what we're ready to do now, the second thing, is we need to do the second derivative. So, and what I'm going to do is I'm just going to put it in this order. If I do the derivative of both sides, the derivative of dy over dx is the second derivative. Okay, then we're going to do the derivative of this, and that part right there, you could either use a quotient rule or you could do a chain rule. It doesn't really matter which way you do that. Okay, and I think what I'll do on this is I'll just do a quotient rule. I mean, it's probably about the same amount of work regardless of how you do that. So I'm going to take the bottom, 2y minus cosine y, times the derivative of the top. The derivative of 5 is 0. And then minus the top, which is 5. And then I got to do the derivative of the bottom. Okay, so if I do the derivative of 2y, that's 2. But you have a dy over dx because the variables don't match. Okay, if you do a derivative of negative cosine, that is negative sine, so that will actually be a negative sine y, and then again times dy over dx. Okay, like that. And I'll clean this up before I do anything else. So the other thing is, in your quotient rule, you have to have the bottom squared, like that. So I'm just kind of working with the quotient rule. And what you're going to find on this, if you take 0 times anything, that'll be 0. And if you distribute the negative 5, you're going to end up getting the second derivative is equal to negative 10 times dy over dx. This part right here is going to be plus sine y. So if I multiply that by negative 5, I'm going to have negative 5 times the sine of y times dy over dx, and then I've still got the bottom squared like that. Okay, so then I'll show you kind of how to finish it up. Does anybody have a question about anything I've done so far? This is what you were asking, Dan? Okay, now here's the next thing that you do. You cannot have dy over dx in there. Okay, why does the derivative of 2y become 2 dy over dx? Okay, because the derivative of 2y is 2. If you're doing the derivative of 2y, the derivative of 2y is the number in front. Okay, so that would be that, and then the variables don't match, so that's why it's dy over dx. Okay, did I have that in there? Looks like I got it right here. I've got 2 times dy over dx, so I think I'm okay. Does that make sense, Annie? Okay, all right. Yeah, it's still a variable, so it's the number in front. Okay, now what you have to do to the next part of the problem, you have to go through and do this. So this is where it can get a little bit tricky algebraically. So I'm going to replace dy over dx with the answer I got on the first derivative. So that will be 5 over 2y minus cosine y. Then I have minus 5 sine y. Again, replace the dy over dx with the answer we obtained to the first derivative. Now, this would be an unsimplified answer to the second derivative. So you have to remember to plug that back in. Okay? Now, you're going to simplify this. So the idea is after I plugged in that first derivative, I need to just get rid of this fraction. So if I multiply the top by 2y minus cosine y, then I would have to do exactly the same thing to the bottom. And I'm only doing that to get rid of these fractions. Okay, and you can do this in your head. You're distributing that through. That will end up canceling that out, leaving you a negative 50 when you cancel that out. Then you distribute this way. That would cancel that out, leaving you, it looks like 5 times 5 or minus 25 sine y, like that. And then the denominator, you just have the same factors for the second and the third and the first. So then you would end up having 2y minus cosine y to the third power. Okay, so that, and this is a good example of kind of the level of difficulty on a second derivative. I only ask a second derivative implicitly for extra credit. But on the extra credit problem on the test, you can get partial credit for it. So if it's a 5-point extra credit problem, and you get the first derivative right, I'm going to give you 2 points. So it's worth doing as much of it as you can. Okay. All right. Anybody have any question about what I just did to get that final answer? Okay, so let's take a look and let me see what else. Jeff, you're asking about number 14. Okay, so I'll go ahead and load up 14 and let's see what we're looking at there. Okay, I'm glad you asked this. Okay, this is a chain rule. This is a guaranteed type of problem on the test. Okay, I'm having trouble zooming in on this for some reason. There it goes. Okay, yeah, good question. I'm glad you asked this question. Okay, this problem right here is going to require the product rule to begin with. Your first being the part that I highlighted in yellow, the second the part in green. And you're going to have a chain rule built within this. So when we do our derivative, just start by putting it in the product rule. So we're going to write down the first, and then we're going to multiply by the derivative of the second, which you can do in your head. I'm just going to go ahead and just put it in the product rule and then continue from that part. Then you have the second, and then you're going to multiply that by the derivative of the first. And these two derivatives right here are going to be chain rules. Okay, so what you're going to have is you just bring down the 2x plus 1 to the fifth. When you do the chain rule here, the 3 comes down in front. You have 4x minus 1 to the second. And then you got to remember to do the derivative of the inside part, which is times 4. That's a common place students mess up on sometimes. Now you would have 4x minus 1 to the third power, and then do this derivative. That would be 5 times parentheses 2x plus 1 to the fourth, and then the derivative of the inside part on that is going to be the 2. Okay? And I'm going to just kind of put this together. I just clean it up a little bit. I got 3 times 4 is 12. Then I've got 2x plus 1 to the fifth times 4x minus 1 to the second. And then over here, I've got 5 times 2 is 10. And then I've got 4x minus 1 to the third. Then I've got 2x plus 1 to the fourth. Okay, so that's the derivative. Like if this was say that this is a plus 5-point problem, then you've earned 3 of the 5 points. The only other thing you have to do is the algebra And this is the part that students have more difficulty with on a problem like this is the algebra. So you're putting this in a factored form. One of the ways that I kind of helped you to do this in class was I said, just kind of draw a box around the two parts of the problem that came out of the product rule, and then look at your common factor. So you have 12 and 10. The number that goes into those two is going to be a 2. 2 is the common factor. So you can pull a 2 out. And then you can also pull out 2x plus 1, but you work with the lowest exponent. So you can pull out 2x plus 1 to the fourth power, and then you can pull out 4x minus 1 to the second power. Take out the lowest. Okay, like that. So that is your common factor. And then you got to figure out what goes inside the parentheses. Okay, now you can do this in your head. I'm going to just kind of review one thing that I showed in class because I do find a lot of times students have a little bit of trouble doing this last part. So what I'm going to do is you could do this on scratch paper if it was necessary for you to do this. I'm going to write down the part that I tried to factor. I'm just going to write it down, take the time to write it down, and then I'm going to divide each part by the common factor. The common factor that we took out was 2 times 2x plus 1 to the fourth times 4x minus 1 to the second. You do this, it kind of takes the mental math out of it. And sometimes students just do it better this way. Okay, so I've got that. Now I'm just going to kind of simplify it. So 12 divided by 2 is 6. 4x minus 1 to the second crosses out. And then you'd be left with just a 2x plus 1 because you have 5 on the top and 4 on the bottom. Okay, and then over here you got 10 divided by 2 is 5. Again, notice that the 2x plus 1s cancel out. And then you would have 4x minus 1 to the first power because you have a third power and a second power like that. Okay, that's the hardest part of the problem that I find for most students. Now, to finish up the problem, what you need to do is you need to go through and just collect all these like terms. So you're going to have 12x plus 6 plus 20x minus 5, like that. And then you can put the like terms together to get your final answer. So your final answer would be written like this. You just have 2 times 2x plus 1 to the fourth times 4x minus 1 to the second. And then that would be 32x. And then 6 minus 1 would be plus 1. So that's your answer to your problem. Okay, that kind of problem will definitely be on the test. I like students to make sure that they know how to do factoring at this level before we get into the stuff we're going to start doing next week. Okay, does that help you on that, Jeff? That was the question you typed in. And everybody else? Okay. Okay, so it's product rule, chain rule, and then there's the factoring aspect on that. The only way to get past that is to practice a few of those problems. They are always going to work out the same way. Yeah, I like it when it makes sense too, Sage, but I also like it when it doesn't make sense. I like a challenge too. All right, so let's see. Number 14. Let me see what else has been typed in chat. I don't see anything else yet. I see 17 part D from Crystal. Okay, so let me go to 17 part D. Okay, all right, that's an interesting looking problem. Okay, so here's what you have to know on this problem. You have to know two things. You have to know the derivative of the secant of x is equal to secant x tangent x, because you are going to be doing the derivative of a secant. You also have to know that the derivative of an inverse sine. Now, I do give you the formula on your formula sheet. So we learned the derivative of inverse sine is 1 over the square root of 1 minus x squared. Those are the two derivative formulas you must know to do this problem. And what you have here is you've really got kind of an inside part. So you're really just kind of doing the derivative of secant u. You start with doing the derivative of the big part. So when we start this problem out, we're going to have f prime of w. So it starts like this, okay? The derivative of a secant is a secant tangent. So we say secant of inverse sine 2w times tangent of inverse sine 2w. It's going to look like a real messy kind of answer. And then you're going to do the derivative of the inside part, which is doing the derivative of inverse sine of 2w. So that's how you start the problem out. You're doing the derivative of the big function, which is the secant of something. Okay, now there isn't going to be a whole lot of simplifying you can do on this problem. You're just going to have secant of inverse sine of 2w times tangent of inverse sine of 2w. And then this is going to go like this. We're going to use this formula. So we do this. We do 1 over the square root. We don't do 1 minus x squared. We do 2w squared. Okay? But since that 2w is another function inside of a function, we also have to do the derivative of 2w to finish up the problem. Okay? So what you would have as your final answer, you would just have all of this would come down. You would have the secant inverse sine 2w. God, I'm writing that sloppy. And then tangent of inverse sine 2w. The derivative of 2w is 2, so we'd have times 2 all over square root of 1 minus, and you could leave that alone, or you could change that to 4w squared. That is your derivative right there. That's one way to write it. You could also put it, of course, in one fraction. Okay, so let's see. Crystal, that was your question. Do you understand what's going on that problem and how I approach it? Okay, anybody else have a question about what I've done? Okay, one thing when you're doing the chain rule is always think about what the big function is. So it's really secant of something. That's why we do the derivative rule for secant. Okay, will we get a sheet listing these identities? You will get a sheet if you look at week 9. What you will get is this is kind of what you're going to see here. Okay, you will get these formulas right here. This is all I give you. I give you the derivative rules for the inverse trig functions. I give you the rules for logarithm and exponential, and I give you linear approximating formula as well. I also posted this on D2L. These are formulas that I don't give you, and I don't give you any trig identities. They won't pop up very much, but there's a possibility that some of the fundamental identities can pop up. Okay, so you want to make sure that you know these rules, but these are the things that I'm going to give you. Okay, let's see. So Annie's asking about 18. Crystal, when using the inverse equation of sine, when do we not need to multiply by the inside like we did with 2w? I'm not sure if I understand quite what you're asking on that. So let me get back to the problem that I just did. Okay. Okay, when do we not need to do that? Okay, well, okay, if you were doing the derivative of just the inverse sine of w, okay, then you wouldn't have to multiply by the derivative of what's inside. I mean, technically it works. Okay, this is 1 over the square root of 1 minus w squared, and the derivative of w is 1. So whenever that variable, whether it's w or x or y or whatever, when that is something else, that's when you're forced to do the chain rule. Okay, that's kind of what you're asking on that, I think. Okay, all right, let's see. So let's see, Annie, number 18. So I'll go ahead and go down to number 18, and we'll take a look at this then. Okay, this one right here you're doing an equation of a tangent line. So ultimately, what we need to do is we need to work with this formula. In this case, I gave you what x was. So that's going to be 1 over square root of 2. And I gave you what y is. That's going to be pi over 3 like that. So the big part of this problem is figuring out the slope of the tangent line, which is going to come from doing the derivative. Okay, so this problem right here, you're given the function f of x is equal to the inverse cosine of x squared. Okay, probably should really put that in parentheses like that. So the derivative rule that I would give you the derivative rule for this is the derivative of inverse cosine is -1 over the square root of 1 minus x squared. Okay, so that is the derivative rule we're going to be doing. Now we're going to do it whatever that rule tells us to do. Okay, the thing is we have to replace that x with x squared. So when you do your first derivative, you're going to have -1 over the square root of 1 minus the x squared part squared. Okay, you're replacing that x in the formula with x squared. Then yes, you do have to do the derivative of the inside part. So the derivative of x squared is 2x. So your derivative is going to be -2x over the square root of 1 minus, and then that will work out to be x to the 4th. Okay, so does anybody have a question about how I did that derivative? Okay, now what we got to do is we got to do the slope of the tangent line. So the slope of the tangent line just means everywhere we see an x, we got to plug in 1 over square root of 2. So we have -2 times x, which is 1 over root 2, all over the square root of 1 minus 1 over root 2 to the 4th power. Okay, so we got to work that out. To me, this is probably the most difficult part of the problem is this part right here is just doing all this arithmetic. Okay, so I can show you a couple of approaches in doing this. What I would recommend is if you have 1 over the square root of 2 is rationalizing the denominator, which is root 2 over 2. So I'm going to go ahead and write this as -2 times the square root of 2 all over 2. That will make that easier to simplify. In the bottom, you'll have the square root of 1 minus. If you do 1 to the 4th is 1. If you do the square root of 2 to the 4th, that's the same as square root of 16. So that's equal to 4. So that's going to give you the 1/4. Okay, that will cancel the 2's out. So you're going to be left with negative root 2. You can get a common denominator for the bottom. You can write that as 4/4 minus 1/4. So this is going to end up giving you, it looks like, negative root 2. And then the denominator is going to be the square root of 3/4. So you could write this as negative square root of 2 all over the square root of 3 over 2. You can do the square root of 4 and get that as 2. So this is a division problem, so it's really negative square root of 2 over 1 divided by square root of 3 over 2. I can invert and multiply, so I just have negative square root of 2 over 1 times 2 over square root of 3. And what that will give me then is, that should give me -2 times the square root of 2 over the square root of 3. Now, you're probably best in this problem to go ahead and rationalize the denominator. Okay, but you have to run through the details of the arithmetic. Now, what I'm going to do is multiply by square root of 3 over 3, because it will simplify this, rationalizing denominator. So the numerator would be -2 times the square root of 6. The denominator would be 3. And that would be what you plug in for your slope. And then the rest of the problem is just basically solving that for y. So I think you could probably take it from there. Okay, I'll do it if you need me to. But you're just going to have y minus pi over 3 equals -2 root 6 over 3. That should be a 3 right there. And then you would have x minus 1 over square root of 2. Okay, so just distribute, and then you could move the pi over 3 to the right side, and then you got it. Okay, so that was your question, Annie. Do you understand what I've done on that okay? Okay, you might get a slightly different answer depending on whether you decided to rationalize a denominator or not. And there's not really that much you have to do on that, okay, from this point. Okay, very good. Let's see. Let me see if anybody else has got something in here. So, okay, I don't see anything else. So what would you like to look at next? Anyone? Just type it in chat. Okay, Jeff would like to look at 22F. Okay. All right. In these problems right here, let me go ahead and just kind of run through a couple of these that are really testing over the same thing. Okay. Like these problems right here, to me, are basically testing this. Now, I give you these two rules. I will give you that the derivative of a to the x is a to the x times ln of a. Okay. Also, I will give you the derivative of log base b of x is equal to 1 over x times the ln of b. Okay, so that's what these two problems have to do with. So if you're doing part F, you've got the function y equals 2 ln of 2x. Okay, so when you do the derivative, you're going to apply this rule right here. You have 2 to a power. The a is represented by the 2. So kind of learn this in words. It's itself 2 ln of 2x times the natural logarithm of the base 2. Okay, but the other thing you have to do is this is a chain rule, so you have to multiply by the derivative of that inside part, which is the exponent. So you've kind of got your basic rule. Whenever you do this, it's itself times ln2 from that rule. Then you're multiplying by the derivative of ln2x. So when you put this together, you're going to have 2 ln of 2x times ln2. There's nothing you can do with that. And then when you do this, this is a chain rule. So what you learned is we learned the derivative of ln x is 1 over x. So this is a chain rule. You're going to say 1 over 2x, then you're going to multiply by the derivative of the inside part, the 2x. Okay, so that's a chain rule. Anytime you do a derivative of a natural logarithm, it's 1 over the function times the derivative of the function inside. All right, so we'll put this together and let's see what we got. So we've got 2 to the ln of 2x power times ln of 2 times 1 over 2x, and then the derivative of 2x is going to be 2. So really the only simplification that you can do is cross out those 2's, and then you would end up having this answer right here. So it looks like your answer on this is going to end up being this. You'll have 2 to the ln of 2x times ln2, and then you would just have, you could put it all over x. Okay, like that, because you have that x in the denominator. That's probably the simplest way to write that answer. Okay, does that look okay, Jeff? Is everybody okay with what I did there? I mean, you have to think always about the big function. Okay, let me do g, because g is the same thing, and just kind of show you how you process this. So if you do g, it would be itself times the natural log of n times the derivative of the exponent would be 2x. That's how you do that problem. That one right there you do in your head. There's nothing else really to do. But F and G are testing over the derivative rule that I'm highlighting in green right now. That's what you're kind of being checked on. Okay. 22H, let's see, Annie, okay. All right, so what we have is we got on the next one, we have H, and we have G of T is equal to the inverse cosine of e to the 2t. Okay, so this is a chain rule problem, and it's going to work kind of like this. The derivative rules you have to know is you have to know the derivative of inverse cosine of x is equal to -1 over the square root of 1 minus x squared. So you're going to focus on that rule, and I give you that derivative of an inverse cosine. Okay, so when I do the derivative, we're going to do exactly what this rule tells us to do. The only thing is, instead of putting an x, you're going to put e to the 2t. So you'll have -1 over square root of 1 minus e to the 2t squared. But then what you have to do is you have to do the derivative of the inside part. Okay? So what we have here is we will do the derivative of e to the 2t. Okay? So now when we put this together, we're going to have -1 over square root of 1 minus e to the 4t. That's a little place where students are bad about messing up on. You multiply those exponents. Anytime you have a power inside parentheses, another power outside, you multiply the exponents. Now that leaves you with doing the derivative of this, which is another chain rule. The derivative of e is itself times the derivative of the exponent. And then what you would do when you put this whole answer together, you would have -1 over square root of 1 minus e to the 4t times e to the 2t, and then the derivative of 2t is 2. Okay, and then you can put this together. The best thing to do probably is just to put it in one fraction and just write the answer as -2 e to the 2t all over the square root of 1 minus e to the 4t. Okay, that would be probably the simplest way to do that. So again, with this problem, it's a chain rule because it's the derivative of inverse cosine of a function inside. That's why I'm multiplying by the derivative of e to the 2t. Okay, so Annie, you understand what I did on that? And everybody else? Okay. The chain rule is, I think, and I remember giving this test last semester to my Calc 1 class, the chain rule really messed up a lot of students. This is the chain rule test. You have to prove to me that you clearly understand when to use the chain rule. Okay, and that's what all of these problems on this page are all about, is do you understand how to do a chain rule? Okay, let's see. Next question. Type something in. Got time to do more. Okay, let's see. Austin, 5A. Okay, so let's see. I'm going to go up to 5A. Okay, so 5A is a quotient rule, and we'll need to make sure that you know the quotient rule then. Okay, so when we do the quotient rule, that's the one where we're doing the bottom times derivative of top minus top times derivative of bottom all over the bottom squared. Okay, so what we'll have here is we'll do the bottom. We're going to do this in our head this time. The derivative of the top is just a 3, and then minus the top, which is 3x plus 5, times the derivative of the bottom, which is 2x, and that's all over the bottom squared. If you have a quotient, then you're going to need to use the quotient rule to work that out. This one, the simplification shouldn't be too bad in this. You've just got 3x squared minus 9 when you do the distributive property. Over here, you got to be really careful about this. You have 3x times 2x is 6x to the second. Then you got that minus that distributes through. Then you have 2x times 5 is 10x. And again, the negative distributes through. So just be sure that you're taking extra care in distributing that negative through. You can do that in your head, or you can do it in a couple of steps if you need to. So what you would end up with doing is just getting the like terms together. So that would be negative 3x squared minus 10x minus 9. That's all you can do in the numerator. And then anytime you do the quotient rule, you don't need to multiply that denominator out. You just always want to leave that denominator alone. Okay? All right. So let's see. That's 5A. So Austin, you asked about that. You feel okay with what I did on that, Austin? Okay, and then Jeff, you were saying 5C didn't have a solution, so I'll go ahead and do that real quick. I don't know why I didn't do that. So this one is a chain rule. You're going to write this as p squared minus p to the 1/3 power. Okay, so this is a basic kind of chain rule. So you would bring down the 1/3, subtract 1 from the exponent, so 1/3 minus 3/3 is going to give you negative 2/3. And then you have to do the derivative of the inside part, which you can do in your head. Derivative of p squared minus p is going to be 2p minus 1, and that's your derivative. And what you would have on this is if I asked you to write it as a radical, which I probably would, you would just kind of put all these things over 1. You would have a 3 in your denominator already, and bring this to the bottom to get p squared minus p to the 2/3, and then the 2p minus 1 is going to be in the numerator. Okay, and then the last step would be just changing that back to a radical. So we would have 3 times the 3rd root of p squared minus p to the 2nd power, like that. So that's the answer if you guys want to write that down. I guess I didn't, I don't know, I guess I didn't either have that problem on your handout or just didn't do the solution. Okay, you guys understand what I did on quotient rule and on that problem 5C, okay? Okay, all right. That's a radical problem, dude. Okay, you guys are funny. All right, what's the next question you want to look at? Okay, 6C and D. Okay, so 6C and D. Okay, all right, so the physics, and these are good examples of what you want to study on the physics on here. So, you know, the number one thing you want to know is how to find the velocity. The velocity is the first derivative, so you want to make sure you know that, which this is easy to do. The first derivative is negative 32t plus 16. The acceleration is the second derivative, so the derivative of the velocity would be negative 32. Okay, so that's what you do there. So now what it says is, when does the stone reach the ground? Okay, so what happens on this is, when the stone reaches the ground, this is basically going to be a parabola that's going downward. Okay, what happens is S is going to be 0. S represents the height, so what you're going to do is solve the equation negative 16t squared plus 16t plus 32 is equal to 0. S of t represents the height of the object, so your job is to solve this quadratic equation. Okay, you could go to the quadratic formula. I'm going to try to factor it. I'm going to factor a negative 16 out of that, and that would leave t squared minus t, and then minus 2 equals 0. Okay, and then we'll see if we can get this factored. So if we factor this trinomial, we'll have t and t to get the t squared. We'll have 1 and 2 to get the 2. And then if we're going to get that to add up to negative t, we need to have a negative 2 and a positive 1 like that. Okay, so that's going to mean that you need to solve the equation t plus 1 equals 0 and t minus 2 equals 0. So this will give you t equals 2. This will give t equals negative 1, but we can't have a negative time. So what we need to have on this is the answer is just going to be 2 seconds. Okay, let me see what you just typed in on that, Jeff, and let me see if I can see all of your question there. Well, okay, you can't, I'm not really sure, I'm not seeing the entire question on there. Can you turn on your microphone, Jeff, and just ask me what your question was on that?
Yeah, I was just wondering why you can't factor out the T in the C, part C.
Okay, because the 32 doesn't have a T. So you can't take a T out. The common factors.
Oh, it's got to be, you can't subtract the 32 first and then.
You wouldn't want to do that.
Set.
You wouldn't want to do that because
Okay.
It's a quadratic equation. And if you solve a quadratic equation, you always want one side equals 0. And then it's either solved by factoring or solved by the quadratic formula. Okay?
Gotcha.
Okay. So
thank you.
The next problem says, what is the velocity when the stone reached the ground? So that means you need to find v of 2. The answer to part C was it took 2 seconds to find when it reached the ground. So your velocity is negative 32t plus 16. So you're going to work out negative 32 times 2 plus 16. So that will be negative 64 plus 16. And that works out to be negative 48. Okay, now I didn't put in, I put that you have feet in seconds. So that would be feet per second. And you need to make sure that you put units. And on the test, I always in boldface type put include units. And a lot of times students overlook at that. Look at that. You're doing physics problems. You're going to have units involved in that. And that's pretty important. If you have velocity, typically would be feet per second or miles per hour or something like that. But acceleration is like feet per second squared. Okay, so if you have an acceleration problem, the units will always be some distance over a time squared. Okay. All right, so that's how that goes. So let's see, I've got that question taken care of now. Okay, so that's one physics thing. What's another problem we want to look at? We've still got 10 minutes to get some more things done. Okay, you can leave early, Sage, if you want to, so I'm okay with that. 23, Crystal, okay. Bye, Sage. Okay, 23. Okay, good question. Logarithmic differentiation. Okay, so you will see one of these things, probably one problem where you do logarithmic differentiation. The first thing that you always want to do when you do logarithmic differentiation is you want to use logarithms to make the problem easier. I do not want you to do the quotient rule. Okay, if you use the quotient rule on this problem, I wouldn't give you any credit because that's not what I'm asking for. So what you're going to do is you're going to take the natural logarithm of both sides. And one of the things that you all have to know is some of these properties you learned in college algebra, like ln of x times y is ln of x plus ln y. ln of x over y is equal to ln of x minus ln y. So you need to make sure you know those things. So what you do is you just bring this down. This would be ln y, and you would write this as ln x minus 1 to the 10th minus ln of 2x plus 3 to the 9th. Okay, you're doing this to make the derivative simpler. The other rule that you learn in college algebra is if you have ln of x to the n, then that n can come down in front of the logarithm. So the other thing I'm going to do is bring this down. I haven't even done the calculus yet. I'm just kind of working with properties of logarithms. So I have ln y is equal to 10 times ln of x minus 1, okay, minus 9 times ln of 2x plus 3, like that. So that's step one when you're doing logarithmic differentiation, is to apply your logarithm rules. Okay. Step two is now you're going to do the derivative of both sides, and you're going to do this implicitly. So and you can kind of do this in your head. You're just doing the derivative of both sides of this equation. Okay, so if you do that, the derivative of ln y is 1 over y, because remember, the derivative of ln x is 1 over x. However, the variables x and y don't match, so you have to multiply that by dy over dx. Okay, now you can do the logarithms in your head. Okay, anytime you do a derivative of a natural log, it's always 1 over the function times the derivative of the function inside. So 10's a constant, just write it down. The derivative of ln x minus 1 is 1 over x minus 1. The derivative of the inside part, x minus 1, is 1. Okay, moving over to the next part, 9's a constant, write it down. Derivative of ln, 2x plus 3, would be 1 over the function times the derivative of the inside part, so that would be times 2, like that. So you're going to put this together, and you'll have 1 over y times dy over dx is equal to 10 over x minus 1 minus 18 over 2x plus 3. Now, we're not done with the problem, but we have done the implicit differentiation. So what you have to do now is you need to be solving for dy over dx. So that means that you need to multiply the entire side. Both sides have to be multiplied by y. And what you'll get for your final answer is dy over dx is going to be all of this stuff, the 10 over x minus 1 minus 18 over 2x plus 3. And then don't leave y in the answer. Y is the original problem. So what you want to do is, instead of having y in your answer, now just tack on the x minus 1 to the 10th over 2x plus 3 to the 9th. And you don't need to simplify these or anything. That's a good answer. Okay, so that's kind of a good review of how you do logarithmic differentiation. Number 24 is essentially the same idea. That's using logarithmic differentiation on that one. Okay, does that help refresh your memory, Crystal, on how to do that? Okay. Okay, very good. Okay, so let's see. One very, very quick question I could probably take. So let's see, Dan. Since it's the simplified answer, the ln doesn't carry with the original equation to sub into y. Yes. You don't have an ln after you do the derivative. When you do the derivative of ln x minus 1, the ln is gone, because the rule is 1 over the function times the derivative of what's inside. So that is 1 over the function times derivative of what's inside. Okay, so that's what you're basically doing on that particular problem when you do that. Okay, so the ln does not carry on, because the derivative of ln makes the ln disappear. Okay? All right. Okay, I need to probably wrap it up here. Now, I've recorded every problem I did, so if you missed out on something, by the end of the day, I'm going to do a review for my trig class in 5 minutes. But you can watch the video, and of course the solutions are posted. So hopefully this will help some of to get you prepared. And then on tomorrow night, if you want to come back, you can, and we'll try to do the other problems that you guys got questions about. Okay. All right. So thanks for coming in tonight. I got everybody's name written down so I can give the extra credit on there. And just keep studying. You still have a couple more days before the test, and work problems. Yeah, work that chain rule out. Make sure you got that under control. Okay, guys, good night. I'll see you on Wednesday or tomorrow night if you want to come in. God, what does it keep doing?